Hi, everyone. Welcome to chapter 3. Now, we'll start discussing real-world machine learning algorithms and their applications. The first algorithm we'll discuss is linear regression. Let's start by reviewing what a regression problem is, and more broadly, what a supervised learning problem is. A supervised learning problem is when our problems have examples and outcomes. Our model learns from previous examples to predict future outcomes. In this specific example that we're going to talk about today, we're going to only have one real example and one outcome, one input, one output. And we'll traditionally refer to this in our specific regression problem as univariate linear regression. So let's talk a little bit about some notation. So when we refer to a single column, X and Y, we want to refer to individual rows. So when we want to refer to a pair of X and Y entries in a row, the first one specifically, we say X sub 0, Y sub 0. And if we wanted to refer to the second row, we would say X sub 1, Y sub 1. Pretty simple, right? Okay. So now, we are talking about a regression problem. We talked about regression versus classification in a previous chapter. And make sure to go to chapter 1 to remember the difference, but I'll delineate that here one more time. A regression problem has a continuous output, which means the output could be some value within a range, an infinite amount of values within some range. And classification problems have discrete outputs. An example of a discrete output might be Lionel Messi scored 1 goal. Lionel Messi scored 2 goals, 3 goals, 4 goals. But Lionel Messi cannot score 4.25 goals or 3.7525 goals. It is a discrete finite output. The output does not exist within some kind of range. So let's talk about the problem we'll be facing today. We have some scatter of data. Let's give an example of, on the x-axis, we have hours of sleep, and on the y-axis, we have grade point average. This data can be modeled linearly. That's our hypothesis, that y is a linear function of x. In other words, y equals mx plus b. Y can be found by multiplying some coefficient m by x and adding it to some value b. Now, if we started guessing, what are some good values for m and b, we could say m equals 0 and b equals 1. And here we have some line that doesn't really look like it's mapping our data very correctly. And then we change the value and say m equals 1 and b equals 1. And again, the line looks a little bit better, but it doesn't look exactly fitted to our data. And then we can change the value of b and say m equals 1 and b equals 1. And you can see that the line is closer to the scatter of data, but it's not exactly right. So now this begs the question, how do we find values of m and b? Make sure to go to the next video to find out how we can find the right values of m and b for our linear model in this linear regression problem.